All right, today we're going to be looking at solving quadratics with the quadratic formula yet again. There's going to be a lot of notes you're going to want to get down because I'm not going to be showing this in class, so it's going to be super important for you to have these as a resource. First of all, just a reminder, here is our quadratic formula, and this piece right here is the discriminant. So this discriminant is going to tell us quite a bit of information. If your discriminant is greater than 0, and is positive, of course, you're going to have two real number solutions. So this is an important piece. If your discriminant is 0, there is only one real number solution. So you can only have one solution there. And if there are no real number solutions, so for example, the discriminant is negative, so we'll talk about negative here, positive here, and 0 here. These are the different types of solutions you would have. So this would be two real numbers here, one here, and then no solution here. I suggest writing these pieces down. Here, let me highlight what I think you should be writing down. So this piece here and this. You don't need the graphs necessarily. This piece here and this here and this. All right, so first things first is I need to get this in the proper format. So I'm going to add 5 on both sides. So this gives us 2x squared minus 3x plus 5. So then I would have a as a value of 2, b is negative 3, and then c is a positive 5. So I'm going to use my discriminant, which would be b squared minus 4ac. Remember, the discriminant is just under the radical. We don't need to worry about the square root at all. So negative 3 squared minus 4 times 2 times 5. So 3 squared would be 9, so 9 minus, so 4 times 2 is 8, times 5 is 40, so this would be a negative 31, which means we would have no real number solutions. All right, let's continue. So we are still going to continue with, I keep putting that negative sign there because I want to do outside, b squared minus 4ac. And in this case, a is 1, b is negative 5, and c is 3. So when I substitute, I have negative 5 squared minus 4 times 1 times 3. So negative 5 squared would be 25 minus 12, which would give us a positive 13. So we would have two real number solutions. All right, so we need to get this equation into standard form, so I'm going to subtract 21. So we would have x squared minus 4x minus 21. So our a value is 1, b is negative 4, c is negative 21. So as we work our way through this, we would have b squared minus 4ac. So b squared would be negative 4 minus 4 times 1 times negative 21. So 16 plus 84 equals 100. So in this case, because it's 100, we would have two real number solutions. All right, last but not least, we do have to manipulate this one as well. So I'm going to get it into standard form. So we'd have 6x squared, and I'm going to add that 13x plus 13x minus 17. So a, 6, b, 13, c, negative 17. So b squared minus 4ac. So we would have 13 squared minus 4 times 6 times negative 17. So 13 squared is 169 minus, actually it's going to end up being plus because of that 17. So we would have 17 times 6 times 4 would be plus 408. So this is a giant number. So plus 169 Now we are at 577. So once again, we have two real number solutions. Again, if you wanted to graph these instead, that's fine, but a graph like this, you're gonna have to zoom either in or out to see probably in, to see those solutions.